In this video, we're going to study the properties of parallelogram. And by the way, this is unit 7.2. I'm one chapter ahead of myself, 7.2. So what are the uniqueness about parallelograms? We know that the opposite sides are parallel. We know that the opposite sides are congruent, and we know opposite angles are congruent, and we also know consecutive angles, or same side interior angles, consecutive angles are supplementary. And finally, we know that diagonals bisect each other. And this is really important, and everything else is determined by the opposite sides being parallel. But this one, you actually can prove it yourself if you wish. And if you have trouble, just come and ask me or Mr. G. Okay, so let's look at how we can use some of these properties. By the way, again, do not memorize it. Draw out a parallelogram and then see by using what we learned in chapter 3 about consecutive angles, same side interior, alternate interior, alternate exterior, and corresponding angles, and figure out if you can prove these properties. It's not that hard to prove. But let's look at let's look at some examples here. Here I have a parallelogram ABCD. It's asking for the length of AD. AD is opposite of BC, so BC is 8, AD must be 8, and DC must be the same as AB, so at 15. And if we know this is 68, I know angle D must be 68 degrees. And then I know angle A is 180 minus 68. That should give me 112. And angle C is opposite of angle A, and it should be congruent. Okay? So let's look at number 3. I have UT is opposite of RS, so UT must be 27 as well. And ST must be 18 because it's congruent to RU. VS, which is right here, right? VS must be congruent to UV at 7, and VT must be be careful here. RT is given at 30. VT must be half of that at 13. Now I want you to pay specific attention that on the diagonals, notice that they bisect each other, but it doesn't mean that they're congruent with each other. They could be. When parallelogram becomes a rectangle, becomes a square, then the diagonals not only bisect each other, they are also congruent. All 4 parts are congruent. But short of that special condition, any other parallelogram, they only bisect each other. Okay? So, okay, let's look at number 5 here. And this one is a bit challenging. I'm going to go through the sides first. So let's break down this problem up to here. I have XY at 15, WX at 22, so then I know the opposite sides are all congruent. And I have ZX is 52. I'm going to break that down into 26 and 26. Just it's easier for me to see. Okay, so now let's see, ZW is at 15 after I marked it up. zy is at 22, tx is 26, and wy, I forgot to mark wt at 23. Then this part has to be 23. So then wy is wt plus ty, which should give me 46, right? So check my arithmetics. So that's the sides. Now let's see if I can erase this. No, I can't erase these things. Okay, I'm going to use a different color. Now let's look at the angles. The angles can be a little bit more challenging, but remember, you're using what we learned in chapter 3. Remember in chapter 3, we went through that if I have a pair of parallel lines and I have a transversal, and then I create 8 angles, right? And as long as I know one of the 8 angles, let's say if I know angle 1, I can find out the angle measure for all the other 8 angles. So if you find this challenging, go back and review chapter 3 or come and see me and Mr. G for a tutorial on that. So let's see. I have WZY. So this whole angle is 72 degrees. I have WXT, which is half of this at 35 degrees. And I have ZWT. ZWT is half of that there, and that's 59 degrees. Okay, so let's see. I'm asking, let's see, it may be easier if I find whatever I can find for now. So for example, I know if WZT is 59, this angle must be 59 because it's alternate interior angles. So these two angles must be congruent. And 35 must be congruent, 35 must be congruent with this angle here. So that's 35 degrees. Let's see if I have enough information. I'm asked about angle measure for TZY. So that's the last angle I drew, that's 35 degrees. TZY, it's right here, right? So let's see if I can have a different color. Here is TZY. And XYZ. So it's this whole angle here. If we know that the angle WZY is 52, then we know that XYZ must be supplementary. So it's 180 minus 72. That should give me 108. Then angle measure XWT. XWT is over here. I didn't mark this one. And so I know that XWZ, the big angle here, must be congruent to this big angle here. And since I know XYZ is 108, then XWZ must be 108 as well. So therefore XWT is 108 minus 59, and that should give me 49 degrees. And finally, XYT is 59 degrees because it's alternate interior angles with YWZ. Okay, so it feels a little confusing because it's running in circles and also because my notes are so messy. So after you solve the sides, I would erase the information about the side length and then mark down the angles and just use what I talked about earlier, using these features that we learned, information we learned in chapter 3, and it's actually not that hard. So take your time and finish the rest of the notes of the first 2 pages. I'm not going to do too much of this part with algebra. You guys are really proficient with it by now. So I'm just going to do one example here. Let's do number 10. Number 10 says if ns is here, is 2x plus 7, and sq is 5x minus 23. And we're asked to find nq. So to find nq, we must find x, and we need to look for a relationship. And we know for a parallelogram that the diagonals bisect each other. So there's your setup. And if you solve it, your x is 10, then you have to plug it back in to your equation. And so you should have 54, I think, right? So the setup here can also be 2x plus 7 plus 5x minus 23, and then you should arrive at the same answer, because S is the midpoint of NQ, because it's being bisected by the other diagonal. Then I can just double this. That's the shortcut I took. Okay. I will do number 14. So I have ABC, the big angle here is at 115 degrees, and I'm asked to find ADB. So in other words, I'm asked to find this, right? So let's see, how do I do that? Now I know, I'll use a different color. I know this angle and this angle are congruent because they're alternate interior, and I also know that 4x plus 6, so that angle, plus 6x minus 11, I added up together, they should equal the opposite angle, which is 115 degrees. So if I set it up like that, my x will come out to be 12 after you finish your algebra. Then you plug it back in. Minus 11, my final answer is 61 degrees. Okay, so I will do a separate video for the next topic, but for now, finish this packet and I'll see you in class. Bye, guys. This video is the second half of 7.2, so we'll call it 7.2b, and it's about proving parallelograms in the coordinate plane. There are 3 different methods to prove it, as you can see, and you need to understand what these 3 different methods are and how different they are. So let's look at the first one. First one says you can prove both pairs of the opposite sides are congruent. And second one says it's still both pairs of the opposite sides are parallel. So either way, either you prove both pairs of the opposite sides are congruent, or you prove both pairs of the opposite sides are parallel. And then the third method is you prove one pair of the opposite sides are congruent and parallel. So it's pretty intuitive, and to do all 3 methods, we're going to use some of the information we learned previously. So look at method 1. Here we say if we prove that both pairs, where's my eraser? So if I can prove that AB and CD are congruent, and AD and BC are congruent, then ABCD is a parallelogram. And to use that, to prove this, I need to use distance formula. Second method, I have, if I prove that AB and BC are parallel, and AB and DC, this is DC, and then AD is parallel to BC, then I have a parallelogram. And to do this, I need to calculate the slopes for all the sides, and the 2 sides that have the same slope are the parallel lines. And the third one is cumbersome. I only have one pair. I need to prove that they're congruent. And we know that if they're congruent, we can use distance formula to prove congruency. And then we have to prove that they parallel to each other. So to do that, we use slope. We use slope formula. So the third method is really cumbersome. Personally, I like the second one the most because it's easier calculation, but the other two are fairly tedious, especially the third one. So let's look at some examples here. Number one, I'm given 4 coordinates. So if you just think about if you have A, B, C, D parallelogram in here, and I have to determine if they're parallel or not. So the coordinates points are given. So I know I can use my distance formula to calculate. Distance formula would be 1 plus 7, x2 minus x1 squared plus y2 minus y1 squared. This would be square root of 68. And then you have to calculate BC using distance formula as well. So that would be 9 minus 1 squared plus negative 2 minus 2 squared. So this comes out to be square root of 164. Then I have to do CD. CD is 1 minus 9 squared plus negative 6 plus 8 squared, and I have root 68. That's good news. Finally, I do calculate DA, the length of DA, so it's 1 plus 7 squared plus negative 6 minus 4 squared, and that should give me square root of 164. So obviously these two are congruent and these two are congruent. And therefore, I just proved that I have a parallelogram, that ABCD is parallelogram. So I will just simply write parallelogram ABCD like that. Okay? So that's using method 1 with distance formula. Problem number 2 is the same, so give it a try yourself and see what conclusions you can draw. Number 3, we're given coordinates again, and now we're asked to use the slope formula rather than the distance formula. So let's see how we can do that. If we have W, X, Y, Z, so we have W, X, Y, Z. I like to draw whenever I can. So if I can just prove that these two sides are parallel to each other and WZ is parallel to XY, that's how I would do it. So let's calculate the slope of WX. I would have Y2 rise over run, right? Y2 minus Y1 over X2 minus X1. So I should have negative 1/4. Slope of YZ is negative 12 plus 13 over 1 minus 5. And that would be minus 1/4 too. And slope of XY, if you do your arithmetic correctly, it should be minus 7 over 4, and then if you calculate your WZ correctly, I'm going to skip it that, I have negative 1. So obviously I have YZ and WX. So YZ and WX are correct. So this is correct. This is parallel. But my XY and YZ are not parallel. So this is no. This is not a parallelogram. Not. So this is WXYZ is not a parallelogram. Okay? So I'm not going to do any more examples. Basically for number 4, problem number 4 is exactly the same way, and problem number 5 is asking you to use both distance formula and slope formula for one pair only. So you need to take two sides, calculate the length, then calculate the slope. And if the length equal each other, the slope equal each other, then you have a parallelogram. The thinking behind it is exactly right. So I'm not going to bore you with more arithmetics. All right, guys, I'll see you in class. Bye.